Good morning. In this PPT, we will be explaining about image captioning and its methods. Section. Every day we encounter images in many ways. Example, the internet, news articles, document diagrams, and advertisements. Humans usually find it easy to interpret these images and give a textual description. However, if machines need to give a textual description of an image, the machines need to understand the semantic and the context of the image. What is image captioning? Image captioning is a process of generating textual description of an image. It uses both natural language processing and computer vision to generate the captions. Image caption generation is the task of automatically generating a description of an image. It involves the underlying of the semantic of the image, which requires the understanding of the main objects, their various attributes, poses, and their interactions in an image. It also needs to infer the underlying semantic meanings to generate meaningful options. Examples of image captioning. In the figure 1, we can see a couple of kids walking around with colorful umbrellas. And in the image 2, we can see a green bird standing on peeled banana in a background. And in image 3, we can see a man in a soccer uniform playing soccer on a field. Next, importance of image captioning. Image captioning is important for many reasons. For example, automatic image captioning can be useful for assisting visually impaired people, intelligent human computer interactions, and developing. Image search engines, platforms such as Facebook and Twitter can directly generate description from the image, where we are, what we wear, and importantly, what are we doing there. It can also be used for event summarization. And image captioning is an important research area. Automatically, automatic generation of image captions requires both image understanding and a language description of the image. Image understanding is a core problem of computer vision. And here are some examples and applications about image captioning. In the figure 1, we can see it would be helpful for a visually impaired people, and it is also useful for human robot interactions. And the last one, it is used for text based image retrieval. And in this slide, we will be explaining about methods of image captioning. We are having three types of methods. They are template based image captioning, and the other one retrieval based image captioning, and the last one novel caption generation. The first method, template based image captioning. Template based approaches have fixed templates with a number of blank slots to generate captions. In these approaches, different objects, attributes, and actions are detected first, and then the blank spaces in the templates are filled. Template-based methods can generate grammatically correct captions. However, templates are predefined and cannot generate variable length captions. The second method, retrieval-based image captioning. Captions can be retrieved from visual space and multimodal space. In retrieval-based approaches, captions are retrieved from a set of existing captions. Retrieval-based methods first find the visually similar images with their captions from the training dataset. The captions are called candidate captions. The captions for the query image are selected from this captions pool. These methods produce general and synthetically correct captions. Method, novel caption generation. Novel captions can be generated from both visual space and multimodal space. A general approach of this category is to analyze the visual content of the image first, and then generate image captions from the visual content using a language model. These methods can generate new captions for each image that are semantically more accurate than previous approaches. Most novel captions generation methods use deep machine learning based techniques. Therefore, deep learning based novel image caption generating methods are our main focus in this literature.
Image captioning methods. We discuss their similarities and dissimilarities by grouping them into visual space, multimodal space, dense captioning, captions for the whole scene, supervised learning, unsupervised learning, encoder and decoder architecture, compositional architecture, and one others group that contains attention-based, semantic concept-based, stylized captions, and novel object-based captioning, and it contains the name of the image captioning methods, the type of deep neural network used to encode image information, and the language models used in describing the information. And next we come to visual space and multimodal space. Deep learning based image captioning methods can generate captions from both visual space and multimodal space. In the visual spaced methods, the image features and the corresponding captions are independently passed to the language decoder. The bulk of the image captioning methods use visual space for generating options. In contrast, in a multimodal space case, a shared multimodal space is learned from the images and the corresponding caption text, and the multimodal space part maps the image features into a common space with the word features. The resulting map is then passed to the language decoder, and the deep neural networks and the multimodal neural language model are used to learn both image and text jointly in a multimodal space. The language generation part generates captions using the information. And next we come to supervised learning. Supervised learning is an approach to creating artificial intelligence, where a computer algorithm is trained on output data that has been labeled for a particular output. The model is trained until it can detect the underlying patterns and relationship between the input data and the output labels, enabling it to yield accurate labeling results when presented with never before seen data. Supervised learning based networks have successfully been used for many years in image classification, object detection, and attribute learning. This progress makes researchers interested in using them in automatic image captioning. We come to unsupervised learning. In our day-to-day life, data are increasing with unlabeled data because it is often impractical to accurately annotate data. Therefore, recently, researchers are focusing more on reinforcement learning and unsupervised learning based techniques for image captioning. A reinforcement learning approach is designed by a number of parameters such as agent, state, reward function, policy, and value. The agent chooses an action, receives reward values, and moves to a new state. Policies are redefined by actions, and values are defined by reward function. The agent attempts to select the action with the expectation of having a maximum long-term reward. It needs continued state and action information to provide the guarantees of a reward function and uncertain state action function. Policy gradient methods are a type of reinforcement learning that can choose a specific policy for a specific action using gradient descent and optimization techniques. The policy can incorporate domain knowledge for the action that guarantees convergence. Policy gradient methods require fewer parameters than reward function based approach. And next we come to dense captioning. In dense captioning, captions are generated for each region of the scene. Other methods generate captions for the whole scene. And the dense localization layer processes an image with a single efficient forward pass, which implicitly predicts a set of region of interest in the image. And it also localizes all the silent regions of an image and it generates descriptions. Region proposals are generated for the different regions of the given image. CNN is used to obtain the region-based image features, The outputs are used by a language model to generate captions for every region. And next we'll see a block diagram of dense captioning.
Architecture. An encoder-decoder architecture was developed where an input sequence was read in entirely and encoded to a pixel-length internal representation. A decoder network then used this internal representation to output words until the end of sequence taken was reached. Encoder-decoder model allows for a process in which the machine learning model generates a sentence describing an image. It receives the image, the input and output sequences of the words. This is also works with videos, as shown in figure. A block diagram of a simple encoder and decoder architecture-based image captioning. Compositional architecture-based image captioning. Compositional architecture-based methods composed of several independent functional building blocks. First, a CNN is used to extract the semantic concepts from the image. Then a language model is used to generate a set of candidate captions. In generating the final caption, these candidate captions are re-ranked using a deep multimodal similarity model. A typical method of this category maintains the following steps. Image features are obtaining using a CNN. Visual concepts are obtained from visual features. Multiple captions are generated by a language model using the information of step 1 and step 2. The generated captions are re-ranked using a deep multimodal similarity model. Select two high-quality image captions. Compositional architecture-based image captioning. A block diagram of a compositional network-based captioning. Attention-based image captioning. It consists of a linear layer that takes pre-encoded image features and passes them on to the decoder. Sequences decoder. This is a recurrent network built with GRUs. The captions are passed in as the input after first going through an embedding layer. Attention-based mechanisms are becoming increasingly popular in deep learning because they can address these limitations. They can dynamically focus on various parts of the input images while the output sequences are being produced. A typical method of this category adopts the following steps. Image information is obtained based on the whole scene by CNN. The language generation phase generates words or phrases based on the output of the step 1. Silent regions of the given image focused in each time step of this language generation model based on the generated word or phrases. Attention-based image captioning. A block diagram of a typical attention-based image captioning technique. Semantic concept-based image captioning. It has the ability to provide a detailed, coherent description of a semantically important objects that are needed exactly when they are needed. Semantic concept of based methods are selectively attended to set off semantic concepts of proposed extracted from the image. These concepts are then combined into the hidden states, the outputs of the recurrent neural networks. The methods in the category follows the following steps. CNN-based encoder is used to encode the image features and the semantic concepts. Image features are fed into the input of the language's generation model. Semantic concepts are added to the different hidden states of the language model. The language generation part produces the captions with the semantic concepts. Semantic concepts-based image captioning. A block diagram of semantic concepts of basal image captioning. Novel object-based image captioning. Novel object captioning aims to generate the image captions capable of describing novel objects that are not present in the captions training data. NOC can add the value to the variety of applications such as human-computer interaction and image language and understanding. This type of methods can only generate the description of objects within the context. Therefore, the methods require a large number of training image sentence space. Novel object-based image captioning methods can generate description of novel objects which are not present in a paid caption datasets. Novel object-based image captioning. The methods of this category follow the following general steps. A separate lexical classifier, a language model are trained on the unpaid image data and unpaid text data. A deep caption model is trained on paid image caption data. Finally, both the models are combined to train jointly in that can generate captions for novel object.